So now we're going to be looking at an example where we're working in radians. I'm going to see if it's any different at all, which isn't really, a bit of a clue. Okay, so let's just keep going here. So we're back to k cos x minus a, so k cos. You see how these kind of all fall in to a similar thing, and the more you do of them, the more you feel confident doing them. And first off, they seem really awkward, but once you do a few, you start to see the tricks and what's going on. So I think about our coefficients. Oh, wrong way around. And cos x here. So k cos alpha equals 1, and k sine alpha equals negative root 3. So k is going to be equal to 1 squared plus negative root 3 squared, which will be equal to 1 plus 3, which is square root of 4 is 2. Cool. Then what you're going to do is you're going to think about the angle. So tan alpha is equal to root 3 over 1. Okay, so alpha is equal to tan inverse root 3. Okay, stop, because this is where so many people will just go and grab the calculators and just stick it in. So first thing to think about is this is one of the exact angles, so we should know this. Another thing to think about is the question is asking us for our answer in radians, okay? And you know it's asking it for radians because of this 2 pi here, okay? That's our big clue. So first off, you might just know what tan root 3 is off the top of your head, but if you don't, that's fine. Because you can think about your triangle. You used to have 60 degrees, 30 degrees, 90 degrees, but for when you're working in radians, you're going to have pi, the computer's crashing, pi over 3 and pi over 6 and pi over 4, and these are still going to be 2, 1, and root 3. Okay, so what angle is going to give us tan to equal root 3 over 1? Okay, so that's going to be, well, that we want that on top, so opposite over adjacent, so that's going to be pi over 3, isn't it? Pi over 3 with alpha. Brilliant. So should we just stick that in the equation and off we go? No, we shouldn't, because we need to think about what quadrant everything falls into, okay, for how much it's been shifted along by. Okay, so let's have a think. Well, cos is positive, so it's positive there, and then sine is negative, so it's going to be positive here and here. So we're actually working in the 4th quadrant, okay? There's 2 pi, that is pi there, and everything that comes in between. So now we need to think about what a is. So a is going to be equal to 2 pi minus alpha, which is 2 pi minus pi over 3, which equals 6 pi over 3 minus pi 3, which equals 5 pi over 3. Okay, and now we can write out our final expression. This is cos x minus root 3 sine x equal to 2 cos x minus 5 pi over 3. Okay, and that's your final expression there. Okay, so things to be careful about in this question. Make sure you're thinking in radians, okay? And another thing, that if you did have a calculator and then you didn't, you didn't bother with the exact angle, which you should, because it is a lot quicker than using your calculator, or it might be a non-calculator paper. Make sure your calculator is in radians. If you don't know how to do that, you need to ask your teacher or ask your friend to show you how to swap between them. You need to be really, really careful when you're working in radians and working in degrees, because when you use these trig functions and you're in the wrong setting, you'll get completely different answers. So please, please, please be careful which mode your calculator is in.